Hi, in this tutorial I want to show you how to estimate sugar content in tomatoes using spectral imaging. In this project we have a set of scans acquired by hyperspectral camera. You can see that each contains one or more tomato pieces. We also have a separate Excel file that is listing for each scan what was the value of brix of sugar content that was measured in the lab destructively after the scanning. Our goal is to build a model that will be able to predict for any new scan sugar content for each tomato. So because we want to work on the level of tomatoes and we want to deal with objects, the first step will be building a pixel classifier. That is something we discussed already in different tutorials, so here we are starting from already defined pixel classifier. Note that we defined the class of background and tomato, and we also defined a separate class of reflection and defect. Reflection is helping us to get rid of specular reflection areas that we don't want to include in the analysis, and defect is removing some of the defects that we also don't want to use for a regression. So we have a pixel classification model that we can apply to any scan, and we can now proceed with regression modeling. For that we need objects, so we will highlight the class of tomato as we will flag it as foreground, and therefore we can segment out individual objects. If we want to do regression modeling, we need to attach numerical values, in this case brix values, to the individual tomato pieces. We could do that manually, that we discussed in a different tutorial, but here we want to import automatically the numerical annotation from Excel file. So we go to our import dialog, and here we have two separate parts. On the left side we can specify the metadata file, the Excel file, and we can point out to the area of the Excel file that contains the scan names and numerical values. So scan names are in column D, and the first cell is D2, and numerical values are in column F, and the first cell is F2. Then we can load values from this file. The second part of the dialog is dealing with matching of the images we have in perClass Mira project into this Excel metadata. The simplest matching is exact, so that means that the Excel file contains exactly the same names as the scan names we already have in perClass Mira. We are in this situation, so we can just click to match the metadata, and we will get for selected image or images in our project the numerical values. Now we can choose how do we attach these values to objects in our image. It can be to the largest one, but in our case we want to attach the numerical values to all objects in each scan. If we click OK, we will see numerical values appearing on our objects. So we can repeat this process for a set of scans, just returning to the import dialog that remembers all the settings, matching the information and importing the numerical metadata. This will provide us with annotated set of scans, and we can progress towards the regression analysis. As with any modeling, it's useful to select several scans and flag them for testing, so that we have some independent validation data to judge the quality of our model, and then we create the regression data set. We see that in our data we have 37 annotations in total, and we will now also see that this is really mapping to 30 objects for training and 7 for testing. Now we are ready to build a regression model. So we got our first regression model trained. You see in this plot the true value and the estimated value of the bricks, and each of these individual points is representing one piece of tomato. The red points are from the training set and green from the test set. When we move around these points, we can see in the status bar which specific point we are looking at, and also the true and estimated value. We would like to improve this modeling, and that can be done in different ways. One would be a different pre-processing. We could, for example, try to smooth the spectra before regression modeling. Let's see if it helps. It actually doesn't. The important value for us is the Q-square statistic. For the test examples, it got a little bit worse. We would like to get it closer to 1. We can try different pre-processing, for example, first derivative, and see what happens. This is a much better picture. That's what we want to see. We are actually getting a high value of Q-square statistic, so it looks like that we have a nice model. What can we do with this model? We can apply it to any scan. That means that the pixel classifier will be first applied, then the tomato objects will be found, and for each of them bricks will be measured. That's one thing that we can do. These images don't need to be annotated in any way. For larger studies, we are often interested in batch processing the data and summarizing the results, for example, in an Excel table. You can do that by exporting regression results for a set of selected scans. perClass Mira will then batch process these selected scans, and if we open the Excel file, we will see the list of images, the training or test status that allows us to separately deal with training and test images in our analysis, indices of objects, size, bounding boxes, if we have, then true regression value attached to these objects, and estimated regression output. So in this tutorial we have seen end-to-end solution for estimating brix sugar content in tomatoes using spectral imaging, having a solution that can be applied to new objects, and being able to batch process a set of scans for further analysis. Thank you for your attention.